Theorem 25. The line that joins the midpoints of two sides of a triangle is parallel to the third side and equals half the third side. So we have triangle ABC that has a segment DE in the middle of it with D as the midpoint of this side and E of the midpoint of this side. And I said D and E are the midpoints of AC and BC respectively, stating that obviously what I just said, D is the midpoint of that side, E is the midpoint of that side. We're going to try to prove, because it's stating that if this line joins the midpoints of the two sides of a triangle, then that side is parallel to the third side. So we're going to try to prove that DE, this line joining the midpoints, is parallel to the third side, and that it equals half the length of that third side. So we're going to prove that DE is half of AB. All right, so the given already stated. Number 2, we're going to extend our line here. Extend the line from D through E, its own length. So we're going to double the length of DE. We're going to extend it its own length, and we're going to call that endpoint F. Extend it to F so that DE equals FE. Before we write the reason, let's just quickly do that here. We're going to extend DE its own length. That seems about right. Maybe not necessarily, but you just have to eyeball it. And we're going to state that it's equal to, we doubled it, we extended it its own length. And we're going to call this point F here. So now we stated so that DE equals EF. Those two lines equal each other. And our reason here would be that a line may be extended or limited. I'm not going to say limited because I'm not limiting this line, but it can be limited. A line may be extended to any point, because obviously the lines go infinitely in opposite directions, and so it's technically there. We just don't draw. We draw small line segments. This isn't even obviously the entire line here. It would go on forever in both directions, so we can extend it to any point, because it literally goes to any point in infinity both directions. Number 3. Now we're just going to connect those 2 points that we have and form a triangle. We're going to draw BF, because 2 points determine a straight line. Okay. So let's connect these 2 points here. There we go. We just created a triangle here. So we actually created a couple figures here. We created this triangle. We also created a quadrilateral. We don't know any properties necessarily at the moment about that quadrilateral. We may in the future of this proof, but we did create a quadrilateral there as well. I do understand there was a quadrilateral already there. But we made one that is possibly a parallelogram. All right. Number 4. I'm going to label some angles up here in this picture. I'm going to label this angle 1, angle 2, angle 3, and angle 4. We can say that angle 1 equals angle 2. Angle 1 equals angle 2 because when two lines intersect, the vertical angles formed are equal. Angle 1 equals angle 2. And I'd like to just say vertical angles are equal. All right. It's not a very in-depth definition or reason there, but it is a true fact because we've already proven that before. Number 5. I can say AD equals DC, and I can say that BE equals CE. All right, let's look at our picture. I just stated that AD right here equals DC, and I've stated that BE equals CE. And I need to make these lines more because I forgot that I've already stated over here that those are equal to each other. And so I need to make these two hash marks just to keep everything correct. All right, so we have now equal line segments here, because we were told in the given that these are the midpoints of the two sides. So a midpoint bisects or divides a line segment into two equal parts. So we could say that those equal each other because of a definition of a midpoint. Pretty simple there. Number 6, we can now say that triangle DEC equals, or is congruent to, triangle FED. Let's look at why we can say that these two triangles are congruent. So I'm saying that this triangle is congruent to this triangle. We have enough information. We said that this side of this triangle is equal to that side because of the definition of a midpoint. We said that this side is equal to this side because that we extended it its own length. And we also stated that these two angles are equal to each other because they're vertical angles. So we have a side equal respectively, an angle equal respectively, and another side equal respectively to another side of another triangle. And so by a side angle side, we can prove these triangles are congruent. Number 7, angle 3 equals angle 4, and FB equals DC. I think we already know what the reason will be here, but let's just quickly look. I said that these angles are equal to each other, and I said that FB equals C or DC over here. So let's also make two hash marks here because it's equal to that. So I said those angles and sides are equal to each other because we just proved that these two triangles are congruent. Because they're corresponding parts, we can state that they are equal to each other. Corresponding parts of congruent triangles are equal. Number 8, we can now say that BF is parallel, I should say, is parallel to AC. Let's look at these sides. BF is parallel to AC. Okay, so we can say that because if we were to extend in our minds these two lines, BF and AC, we would realize and see more clearly that we have a transversal cutting those two lines. We don't know that they're parallel yet, even though we just stated it. This is how we can know that they are parallel, because we have a transversal, and we've stated because of CPCTE that these angles are equal to each other. Well, if we have two straight lines being cut by a transversal and their alternate interior angles are equal, that means that the lines are parallel. So that's why we can state that those two lines are parallel. Number 8, if alternate interior angles are equal, then, I should say alternate interior angles of parallel, two straight lines, I apologize, two straight lines are equal, then those lines are parallel. Number 9, we can now state that AD equals BF or FB. We can say that this line equals this line. And we can already see it. They both have the same amount of hash marks. Because if this line equals that line, then this line, and this line also equals this, then this also equals that. Substitution there. Or quantities that are equal to the same or equal quantities are equal to themselves. So we can say that AD equals DF. Let me make that better there. AD equals BF. Because in really the short way, it would be substitution. Step number 10. We're going to say now that quadrilateral ABFD is a parallelogram. And we can state that because a quadrilateral with two sides both equal and parallel is a parallelogram. Let's take a quick look and move on. We stated that these two sides are equal. We stated that these two sides are parallel. So we can now state that since they're both equal and parallel, that was one of the things that we've proved in a couple videos ago, that would cause this entire quadrilateral to be a parallelogram. All right, number 11. Number 11, I can now state that DF equals DE plus FE. Let's go up so you can kind of see what I'm saying. DE plus EF will equal DF. There it is, DF plus, or DE plus FE equals DF. And so we can say that the whole, number 11, the whole is equal to the sum of all its parts. All right, number 12. We're going to kind of switch things up a little bit. Let's actually say this as well. We should probably state that AB equals DF. That's important to state for what I was about to say is actually. So AB equals DF. Again, DF equals AB, AB equals DF. We've already stated that this entire thing is a parallelogram, and we know, and because we've proved it, that opposite sides of parallelograms are equal. And we've said that this is a parallelogram, so the opposite sides would then be equal to each other. So AB equals DF, because the opposite sides of a parallelogram are equal. Number 13, I can say that DF equals DE plus DE. What in the world? Why in the world am I saying something like that? Remember in our step 2, we stated that DE equals FE when we extended that line DE its own length. We said so that DE equals FE. So they equal the same thing. They have the same quantity. So if we can add these two things together, which equal each other, we can substitute FE, and we'd get the same quantity if we add DE plus DE. And I over here said equals DE plus DE here. There we go. If we add DE plus DE, it's the same exact thing as when we're doing DE plus FE. We'll get the same exact quantity. All right. So now number 14. Oh, I should probably say the reason here. We just substituted there. Substitution axiom. Number 14, I can say DF equals 2DE. That's just algebraic simplification. Algebraic simplification. Okay, number 14, all we did was combine like terms. That's not rocket science there. Now we're going to substitute another time. Now we're going to say that AB equals 2DE. Again, we've already stated that AB equals DF. So if DF equals all this, then that means AB has to equal the same thing. So if DF equals 2DE, that means AB has to equal 2DE since they equal the same thing. That's just substitution axiom there. Substitution. And then number 16, we would just divide by 2 to both sides. This would be the division axiom. We can divide both sides by the same quantity and we'll still get equal quantities. So if we divide AB by 2, we would get 1/2 AB equals just DE. That would be our division axiom. And then number 17, we would also now just state one of the other things we needed to prove, and we can say this without anything else that needs to be said. AB is parallel to DE. So again, we said that this is a parallelogram, and the definition of parallelograms is that the opposite sides are parallel. So AB would be parallel to DE. Pretty simple there, definition of parallelogram. Quite a lengthy proof here, longest proof thus far here in the videos. Theorem 25, the line that joins the midpoints of two sides of a triangle is parallel to the third and equals 1/2 the length of the third side.